This is video number 1 for the 4th exam, sample exam number 4 for Math 107. For the first one, we just have to prove that the following functions are inverses of each other. To prove their inverses, we have to use the operation of composition. Let's go through what composition is for review. F composed with G is a function of x means that F is the outside function, G is the inside function. So having done that, you go up and find out what G is and write it in. So this is x minus 3 raised to the 1/3 power. So that all goes right in here. Now you evaluate F. Here's your F using this function. So every place there's an x, I put that. So I've got x minus 3 raised to the 1/3 power, and then I have to cube it because this is that x we're talking about right here, adding 3. Well, 3 times 1/3, remember exponent on exponent, you multiply. This becomes x minus 3 plus 3 equals x. So if you get the x back, they're inverses of each other. You could just as easily have done G composed with F and you would get the same results. Now in this case, if you get off on the wrong foot, you're going to have some trouble. This isn't too bad. Let's think of it this way. You've got two allowance schemes. There's one where you start with $10 and every week you get another $10. So here's the allowance for your brother. He starts off with 10, but every week he gets another 10. So that's 10 times t, and t is the number of weeks. So in 2 weeks, this would be 2, so he would have gotten two $10 raises, which is 20, and he'd be getting $30 a week. Now in your case, you choose 1 penny to start, and every week your allowance is doubled. This is your exponent. Remember this kind of wording. It's doubled. It's not multiplied by 2, it's doubled. It might say tripled here. We'll go through that in a minute. So here's your allowance. Remember that in an exponential equation, you have your starting value is A0. And if it's doubled, then it's multiplied by 2 raised to, it's growing, hopefully not decaying away, so it's t divided by some time constant. Let's just use this basic equation is all you need here, right? Your initial amount is 1 penny. We'll write everything in dollars, so this is 0.01. It's a cent, okay? Times 2 to the t. That means every week it's doubled, and that is the expression for it. This could be in parentheses or multiplied. What happens if your allowance is tripled? If it's tripled, then you would start again with your 1 penny. I should have put it in dollars, and you'd multiply it by 3 to the t, because that would have the effect of tripling. This is why you have to get off on the right foot, because you have to have the right equation to start. So here we've got the amount that you get for your allowance is your starting amount, which is your 1 penny, multiplied 2 times 2 raised to the t power, and that will give you your doubling effect. Now the question is, how many weeks until you get an allowance of $1 million? This is why everything has to be in dollars. What does $1 million look like? Well, it's 10 to the 6th, if you remember that. Or you could write it out with a whole bunch of zeros, but I'm going to write it as 10 to the 6th. And this is, what is that anyway? It's 10 to the minus 2. Helps to know your exponents. 2 to the t. So this is good practice with those exponents. Now, you need to get the t down from being an exponent. You're going to use logarithms. But before you do that, you might want to clear this constant. So I'm going to divide both sides by 10 to the minus 2. 10 to the minus 2. Now here you get a little practice with exponents. Same base, you divide. What do you do to the exponents? You add, you subtract them. 6 minus a negative 2 is 10 to the 8th. Alright? And on this side, you have 2 raised to the t power. Okay, you need to get that t down, so I'm going to take the log of both sides. You could take ln or you could take log. Remember, there's no calculators, but there is a reference section with values in it. And if you get stuck and you can't evaluate things, you can at least do all the work, which is the most important part. So I'm going to take log, because that will help me over here. So I take the log of both sides. 10 to the 8th equals log of 2 to the t. It has to be the same log. What happens to the 8? It comes out in front. 8 times log 10. but I know the log of 10 is 1. Okay. Over here, the t comes out in front, and it multiplies the log of 2. All right? Look what's happening again, just for clarity. The t comes out in front and becomes a multiplier. Log 2 is a number. Log cannot stand by itself. It must have a number after it, right? Or a variable after it. Log of 2, what is that anyway? You can look in the reference section and find out it is 0.3010. So I have 8 equals 0.3010 times t. So just isolate t by dividing both sides by 0.3010 and get the answer. Okay, let's look at these steps one more time. First, it's helpful to start off with the right equation. Then write your equation, substitute your numbers. It's nice to use exponents because that works out better. 10 to the 6th, and now 0.01 is 10 to the minus 2. All right, times 2 to the t. Get the constant over to the other side. So you have this problem here. 10 to the 8th equals 2 to the t. You want t to come down so you can solve for it. So you take the log of both sides. Log of 10 to the 8th is just 8. The log of 2 to the t is t times the log of 2. Log of 2 doesn't just vanish from the problem, but you can find its number in the reference section. It's 0.3010. If you don't find it there, you of course can still divide by it. This following question may or may not be on the exam, or it will be in a modified form. You're given the log of x, and let's just do one, the log of x minus 2, well, I'll do all of them, and the log of 2x. Now, if you want the log of x to be 0, there's one place where the log of x is 0. That's when x is equal to 1, right? When is the log of x minus 2 equal to 0? When the argument of log, that be your x minus 2 equals 1, then it will be 0, in other words, when x is 3. This is just a shifted log, right? And now again, you want the log of 2x to be 0. It will happen when 2x is equal to 1 or x is equal to 1/2. Oh, wait a minute, I'm sorry, that's ln. Same thing. Logarithms of 1 is like this. Log of 1 equals 0. However you get that 0, by one of the values of x, that will set that to 1, then the answer will be 0. That's the first question right here. Okay. Now, when is this function equal to 1? Oh, I need to erase it. All right, let's start with this one. When is the log of x equal to 1? Well, it's equal to 1 when x is 10, correct? The log of whatever base, this is base 10, of 10 is equal to 1. So if you have log of base 10, whatever's in here has to be 10 in order to be 1. So let's look at the next one. Log of x minus 2 equals 1. That will happen when all this is equal to 10, or when x is equal to 12. Now the natural log of is really to the base e. So when its argument is e, then it's going to be 1. So when I take the ln of 2x equal to 1, that will happen when 2x is equal to e, or when x is equal to e over 2. Now, vertical asymptote of the log function, if you remember what log looks like, log is not oh dear.